Okay, so we're close. 1 squared is, what's 1 squared? 1. This second part there might not be so easy. I mean, you should learn this when you do exponents in school, but some people still get tripped up. So how do we evaluate that? X to the 2 to the n plus 1 squared.
2 to the exponent. Add 2 to the n plus 1. No, 8.
Okay, so you're saying we should go x to the 2, and then we have n plus 1, and then we add the 2 there.
Yeah.
Okay, unfortunately that's not right. Okay, you.
2n plus x squared to the 2n plus 2.
Okay, that's the final answer, but how do we get there?
Multiply the n plus 1. Oh, don't you factor
Wait, so, okay, so you're saying take the n plus 1 and then multiply by 2. Unfortunately, that's also wrong.
You factorize the numerator.
No, we don't want to factorize the numerator, unfortunately. So many hands here. Let's go you.
Multiply 2 to the n plus 1.
Okay, so we take 2 to the n plus 1, and then we multiply that by 2. Remember, one of your laws of exponents, x to the power of m to the power of something else is just x to the power of the product of the two. So you have x to the power of something, which is that, to the power of something else, which is 2, you just multiply the exponents. Now, how do we multiply two things that have exponents that have the same base? You add the powers. So you've got n plus 1, 2 to the n plus 1, and then you add a 1, because 2 is just 2 to the power of 1. And that's how you get 1 minus x to the 2 to the n plus 2 over 1 minus x. Is that the right-hand side we were hoping for? Because what we were hoping for was that with n replaced by n plus 1. So yes, good. Everyone happy? Yes? Good. What time is it? 7. It's having so much fun. Okay, so this, oh, not that, just there. I want you to go home, write up a proof for that by induction. So that's difference of n powers, you probably saw it in school. I want you to write up a proof for using induction for why that is true in general. Write it up, give it to me next week. Cool.
Does anybody know why it's called the principle of mathematical induction? Where does that title come from? Why is this process here? Why is it called principle of mathematical induction? Please?
Well, I mean, one of the steps is to assume for the nth case. So, like assuming like reducing and supposing they're sort of synonyms in this case.
Okay. And there's a name given for that step where you assume the step. What is the name of this statement? Very good. Can you say it louder so they can all hear?
The induction hypothesis.
Yes, the inductive hypothesis. Okay, the whole proof by induction revolves around that inductive hypothesis, and that's what the process of induction is. Okay, does everybody understand what induction is and why we use it? If you can get to the first step of the staircase, then you can assume that you can get to the second step, and if you can get to the second step, then by induction you can get to the third step, which means that by further induction you can get to the next step, and so on. All right. And what you mentioned there, Liam, about You saw it in the Maths Olympiads that students use things that they're supposed to prove. They use that in the proof. It's not just in the Olympiad. Okay, it also happens, and the teachers who are here will vouch with me that it also happens a lot in the trick. When you're asked to prove things in Euclidean geometry in one of the riders. So now, for example, you're asked to prove that a line is a tangent to a circle. Somewhere in the proof, they've assumed it's a tangent and they've shown that the radius is perpendicular and all sorts of things, but that was what you were trying to prove. Okay, so you've been made aware of that this evening, that you must be very careful that you don't ever use stuff in your proofs that you're supposed to be proving. In a nutshell, can you finish off in one sentence?
So induction is like, okay, have you guys seen those cool things where you have a row of dominoes and you knock one over and they all fall down, and then it makes like this beautiful picture of your mom. So that's kind of what induction is. You knock over the first one, and whenever one of them knocks over, you knock over the second one, and it just keeps on going. So that's what induction is.
I think that's a very nice way to do that. And then, in a nutshell, Jonathan, would you like to just finish off and say goodbye? And I really hope that the grade 10s and 11s here will see you again with Jonathan.
Yeah, so I like counting things. That's my last one. I guess maybe a check that you've got it for induction. Just think about the case of what happens if you can't prove the base case, but you can prove the inductive hypothesis. Well, then you know that everything beyond a certain point, everything beyond a certain point is there, unless absolutely nothing is. And then if you can show that 3 isn't, well, 2 and 1 aren't, because otherwise they'd have knocked over 3. So really in that case, what you know is that you've sort of got this bunch of numbers where it's false, and then this other bunch where it's true, and possibly one of those is empty. But think about why, if you only have the inductive step, that this is kind of the picture, and that may help with, if this isn't entirely obvious to you, with what's going on.
Great. And be careful, those of you who are doing AP Maths, and of course you will get your proof by induction in your exam. The people who mark it are not stupid, and if you fudge your proof and then go hence, the statement is true by mathematical induction, you're not going to get any marks. Okay, so rather don't waste time, move on to other questions. If you really can't prove it, don't pretend you've proved it. All right. Okay, great. We've had a lovely mathematical evening together. Drive safely, and we'll see you next week, Tuesday.